Hello everybody. It's great to see you all here, and thank you for attending this talk. So my name is Rommel Joven. I'm a malware researcher working in Fortinet, FortiGuard in Singapore. So my co-author is Floser Bacurio Jr. He's a senior malware researcher, and we're working both on the same team. Unfortunately, he can't join us today. So as you can see on the screen, our topic is Lucky Strike, smoking the Locky ransomware code. As we all know, for the past year, this ransomware has been very popular and became one of the most prevalent family in the ransomware industry. So this is what you would expect in this talk. First, we'll take a look on the success of Locky compared to other popular ransomware. Second, I will share on how Locky developed over time. So it's like a history of Locky from its first appearance last February 2016. Third, we will delve in the detailed analysis of Locky. So this includes its configuration, CNC communication, and file encryption. The fourth one, we will share details on the system that we built to automatically harvest this Locky's configuration. And then next, having monitored Locky for more than a year, we will share our findings on the kill chain, specifically the spam campaign of Locky. And lastly, additional stuff that we found to be interesting. And after the presentation, there will be some Q&A. So let's begin. So first on the list, everyone must be familiar with this. So this is the WannaCry ransomware note. This is the ransomware that made an outbreak back mid-May. So I did a little research on WannaCry that hits Switzerland, and I think only around 800 was hit, so that's a good thing for Switzerland. So next, the interesting in WannaCry is it wasn't the typical ransomware that arrives by spam email or malicious websites. So it took advantage of the leak exploit from the NSA attack tools. So with this, it was able to hijack hundreds of thousands of computers across the globe in a matter of hours. So let's take a look at the next one. So it is the server ransomware node. And this ransomware is one of the most successful ransomware as a service that is offered in the dark web. So servers creator are particularly nurturing when it comes to this ransomware, that they constantly update and make improvements to be more effective. This is the reason why it still remains prevalent. So comparing the two, we have WannaCry, which had a short lifespan that lasted less than a month, while in the other hand, we have the server ransomware, which has been in the ransomware for quite some time. And now we have here the Locky ransomware. So having seen WannaCry and server, how do you think Locky will match up with these two ransomwares? So to give us an idea on how these three ransomware matches up, we will take a look on the lock-in profits made by this ransomware. Since most ransomware the purpose of ransomware are profits, so we will compare their profits. So how profitable is ransomware? So what we have here is a chart of the profits made by the most prevalent ransomwares. So this has been research from the Google's research team that trace end-to-end payment from the Bitcoin wallets used by ransomwares. So whenever you see the ransomware site, you will see a Bitcoin wallet of this ransomware. So that's the one that Google traced. So you can find out more in the reference Eli.net. He explained more on how they trace this Bitcoin payments. So now taking the data included here are ransomware from year 2013 up to the second quarter of 2017. So it's quite updated. Now taking a look at the graph, we can see that Locky earned a whopping $7.8 million and server $6.9 million. And both of them took major of the profits, with Locky leading the way by a short margin. Comparing to WannaCry, so if you see in the bottom, it earned only around $100,000. So even though WannaCry became a household name last May, why wasn't its popularity turned into direct profits. So the reason could be, first, the famous kill switch, that a registered domain could stop immediately the infection. Second, victims just didn't want to pay since decryption had issues. So when researchers reversed WannaCry, they saw some issues, that there were no assurance that the files would be decrypted back. And third, since WannaCry took advantage of an exploit, which already had an available patch, I think last March or April, this means that updated computers weren't vulnerable at that time. So the major difference of WannaCry from Locky and Cerber is that Locky and Cerber uses the business model called ransomware as a service. So since ransomware is a big business on the dark web, its creators realized that they could make more money not just by extorting digital currency by themselves from their victims, but by selling the ransomware kit to other cyber criminals that will help spread their ransomware. So, yeah. So majority of the success of Locky, as seen in its profits, could be attributed to its affiliate program. So when we say affiliate program, it is a program where third-party cyber criminals or other cyber criminals help spread the Locky ransomware. And with this, in the potential victims, they would have a pay-per-install commission. So both earn the creator of Locky and the other cyber criminals both have profits. So here are the list of the affiliate IDs that we have determined so far, and had found at least 8 affiliate IDs. So we classified these affiliate IDs into methods used, such as spam email and compromised sites. So we have 1, 3, 5, 15, and 21, and we observed that these affiliate IDs use the attack vector for spam email. And this spam email can contain any malicious attachment like scripts, MS Office, PDF, or any other file types. Then for 13, 24, and 1E, we observed that this came from compromised sites that redirect to nuclear or neutrino exploit kit. So to keep track of these installs, Locky binaries contain these affiliate IDs embedded in its Locky binary code. So we'll talk about this more later. So aside from affiliate distribution method, Locky also aggressively updates itself for some reason, like AV evasion, configuration improvement, and so on. So now let's take a look at Locky's development for the past year. So in February, it first appeared in February 2016. So the sample was pretty straightforward. So if you do reverse engineering, then once you open it, then it's not packed or not encrypted. So reversing it is quite easy. And it was easily identified as Locky since it uses the hard-coded Locky string for its registry key. So once you see the Locky registry key, it means that, yeah, it's from Locky ransomware. Then, as mentioned on the affiliate program from the previous slides, so under the configuration, we can see the affiliate ID. So it's included there, and the CNC servers. So the next month, the sample is already packed. So after a month it released, it packed and encrypted itself, and its configuration is also encrypted. Its registry key, which was former Locky, is now based from the computer's volume GUID. The DGA is now updated and now based on the DGA seed found from its config. So if you can see the font in red, it's the added configuration flags in the configuration. So in just a month, this ransomware already shows its big impact in the wild. For April 2016, another improvement is the custom encryption of HTTP communication with the CNC. So the HTTP traffic are encrypted now using both AES and RSA. So it's more difficult to trace. And for the configuration, there's again another entry, which is the URL path. So in May 2016, the encrypted HTTP post data is now encoded using percent encoding. One possible reason of this change is to avoid suspicious look of packet, since percent encoding is usually used by legitimate sites. So we move on to June 2016. Its loader now requires an argument to execute properly. So actually, this argument, like 123 and 321, is a decryption key used to decrypt the next layers of code. So if you execute this sample without these arguments, then it won't run properly. So Locky used this as a anti-sandbox technique. So if you load this sample without the argument, so it will not show its true payload. So it will not be detected by sandbox. Next thing, also in June, Locky changes extension of its encrypted files into Zepto. This update caused a little bit of confusion to some researchers at that time, which they thought it is a new ransomware family, since usually ransomware family is based on the extension added to the encrypted files. So apparently, Locky and Zepto was just the same. And in the same month, in July, next month, it added the capability of online encryption. So when we say offline encryption, it doesn't need any connection to its CNC. So even though there's no network traffic, as long as it runs in your computer, then it will still be encrypted. So it also added ampersand v equals 2, or it could mean like version 2 of Locky, which has the offline and online encryption capability. We'll discuss this more later. Then in August, we saw that Locky's binary switched from executable to DLL, which is loaded using run DLL32.exe. So one possible reason for this update is to bypass heaps, as some security vendors will not perform behavior analysis on run DLL32.exe. Then September, we saw that Locky uses the NSys installer package as its loader. So this could possibly evade AV detection, and also it causes problems to create more generic signatures, since a lot of malware uses this NSIS packer. And on the same month, it changed again its extension to .odin. So Locky continues to update itself every month. And in October, it continues to spread in massive spam campaigns. And now it changes its extension to .sheet and .tor, sorry. So yeah, and also the URI changed to linuxsucks.php. So yeah. So Locky regularly changes the URI, since this URI is used for its CNC communication. So if they use the same URI, it's most probably blocked already by security vendors. So they constantly change it to evade this detection. Moving on from November. So yeah, some extension change, .acir and .zzz and URI. So not much major changes. Then in December, before 2016 ended, it changed again its extension to .osiris. So as you have seen, there's a lot of changes in the extension, but generally they are all Locky ransomware. And common during December, cyber criminals, and Locky included, take a Christmas break. So and malware hits drop down for Locky in December. And it goes also for, and 2017 came, so Locky extended this break at the first quarter to January, February, and March. So we didn't notice any spam campaign, and our speculation was that Locky Authors was preparing for a new Locky to be deployed. So moving on, April 2017, after a 3-month-long break, Locky came back using the same Osiris extension. Then again, later that month, it changed to loptr. So for us, it wasn't a complete comeback yet for Locky, comparing to the havoc that it made during 2016. So again, for the following months, May, June, and July, there were no changes again, so we will skip these months. So moving on to August, this is where we can say that Locky really is back. So it had 2 new extension change within a week, which is Diablo 6 and Lucitus. Then reports were coming in from different security vendors saying that they have reached like 23 million in volume, and some even say that they have observed 60 million of spam emails. So that only means that Locky pushes in a massive spam campaigns. So also Locky's loader. So before Locky's loaded, it also has an update. It has a new anti-VM and anti-sandbox trick, since it will only start the PowerShell to download Locky when the document is closed. So for example, you open the document in Sandbox, then it won't do anything. But once you close that document, that's where the PowerShell will download the Locky. So yeah, it's quite tricky. So if you didn't know that you need to close, then nothing will happen, even if you enable macros. Okay, so next, September. So the spam campaign continues with new variant, which is YK call, or just inverted Locky. And then October came last month. Again, a new extension, which is that assassin. So interesting also is the loader, which now serves 2 malware. So the loader gets first the GeoIP of the machine, and if it includes the following countries: UK, Australia, Luxembourg, Belgium, or Ireland, it will serve the TrickBot malware. However, if it's not from those countries, then it will still serve the Locky ransomware. Also, some malicious word doc attachments use the DD exploit to download and execute Locky. So with the momentum that Locky has now, we continue to believe that there will be more updates on the loader and Locky itself for the upcoming months. So after seeing the history of Locky, we'll now take a look on the technical analysis of Locky. So as I was mentioning a lot about the configuration, so this is a sample of its configuration. So we'll try to understand what this configuration do, and why is it important to Locky. So the first thing that Locky does is to decrypt this configuration, which is embedded in its binary. So this configuration is important since this will affect some of the behavior decisions of Locky. So we will take a look at each flag in the configuration and how it affects Locky's behavior. So first is the affiliate ID, as mentioned in the beginning. This indicates the individual who spread the ransomware. So it's 5. Next is the next 4 bytes is the DJA seed. This is used to determine the future domains to be used as the fallback for Locky to connect to its CNC. Next is sleep. This flag dictates the duration of sleep in seconds before executing its main behavior. So the longer the sleep by Locky could affect some automated analysis to timeout, and resulting for Locky to be undetected. So next is only a byte. So it is to drop as SBCOs.exe. So if it's 01, it will drop as drop and run as SBCOs, and if it's 0, it will just run as normal. Next is auto run. This is for persistence, like adding the startup registry. So to run Locky at every startup. Next is check Russian config. So Locky checks the user and system default language of the computer. So if it is found as Russian, then Locky will close and delete itself, meaning it won't infect computer with Russian as their default language. So if you set your language as Russia, then you won't be infected by Locky. Yeah, it's tested. Next is the CNC offset. So next in the configuration is the URI. As you can see, it's userinfo.php. So this one is one of the constantly changing in Locky's development. So this URI will be appended to the hard-coded IPs, as you can see below. So far, Locky has 13 total URI changes since its first appearance in February. And last in the configuration is the CNCs. So we have 3 sets of IP there. So here again is a quick look on the online configuration. And if you remember that one of the development of Locky is it has its own offline encryption mode to encrypt files. So we will compare the difference of the two modes. So we have here the offline mode, and we have here the online mode. So comparing to the online mode, we will see some major differences. So first, there is no DJSID since it doesn't need to connect to its CNC. Next, there's no CNC offset and no CNC and URI. So basically, all the configuration needed to connect to its CNC has been removed in the fully functional offline Locky. So you may ask, like, how will Locky encrypt itself if it doesn't connect to its CNC and get the RSA key? So what Locky did is, for the offline mode to successfully encrypt the data, Locky stored, if you see the address, it's 19800. So just below it, the configuration, it added the embedded public RSA key. So one loophole of the offline mode is that, in theory, one private key or the decryption key could decrypt all offline mode Locky with the same embedded public RSA key. So it doesn't only include the RSA key, it also includes the embedded ransomware text and the embedded HTML ransom HTML and text. However, for the offline mode, this only supports the English language. So after decrypting the configuration, Locky proceeds now to create the victim ID. So to be able for Locky to identify the victims, it has to create a unique ID for each victim. So this is for online. So since offline mode has a different victim ID. So for the online, it will take the volume GUID of the Windows directory. So this GUID will be hashed using MD5. And then the first 16 characters of the MD5 will be the victim ID. So an example is seen below. And for the offline mode, so for Locky to tell apart between the different offline victims, it creates this special victim ID. So first, the GUID. We have the default language, the OS, domain controller, the affiliate ID from the configuration, and the public key ID since it has the RSA key there. And after, it will be encoded using a hard-coded 32-character value. So, and an example of the offline victim ID is as seen below. So if you notice, the affiliate ID and public key has a part in creating the victim ID in the offline mode, since this will assist the malware authors to determine the affiliate since there is no CNC connection. So next, after decrypting the configuration and creating a unique ID, Locky now proceeds to connect to its CNC. This is for the online Locky only. So here is a quick overview on the CNC's behavior. It first tries to connect to its hard-coded IPs, and then if yes, it just starts posting requests. Then if no, it uses the DJSID in the configuration to create some domains. And here's an actual data, the data before being encrypted, which will be sent to the CNC. So we have here the key, and it uses the ampersand as its delimiter. So first is the victim ID, as we discussed a while ago. Next is ACK, or action. So these actions are get key, get text, get HTML, and stats. So get key is to get the RSA public key from the CNC. Get text is to get the ransomware text. Get HTML is to get the HTML ransomware text. And stats is the how many files are encrypted, how many are failed, and yeah, that's it. And then next is the affiliate ID. Then we have the language. Since Locky is multilingual, it retrieves the default language of the victim. So this will be used to determine the language of the ransomware note when requested to the CNC. So if it's not English or it's a different language, then that's the corresponding ransomware note that will receive by the victim. Next is corp, or this could stand for corporation, and it tells if the infected user is a member of a domain, which could mean it infected a corporate computer. So we have this value 0, 1, and 2. Then server, if it's a server or not. So as you can see, Locky retrieves this information like the server and corp. So it can have an idea of the value of the data that was encrypted in the infected computer. So this now could determine the number of bitcoins Locky will extort from the victim. So if you see on reports like hospitals pay this and schools pay this, since Locky gets a lot of information to determine how important the computer that's been infected. So next is the operating system, the service pack, the architecture, and this is the version, so version 2. Next, we'll proceed to, so this is just how the victim and the CNC talks to each other. So the victim get key, CNC sends the RSA public key. The victim posts the get text, then it will respond the corresponding ransomware text. It will get HTML and correspond with the correct language ransomware HTML and stats. Okay, then next, after connecting to the CNC and having the RSA public key ready, so it will now proceed to the file encryption. So these are the targeted drives by Locky. So removable, fixed, remote, RAM disk. So it infects all possible drives connected to the user. And these are some extensions. So we found that around 460 extensions are being targeted by Locky. So now we have the file encryption. So if you notice, we have two keys here, the RSA and AES. So when we think about it, why did Locky still use an AES for file encryption when in fact it already has the RSA key, which can be used already for encryption? So one possible reason is in terms of performance. So AES would be more efficient than RSA, since AES uses symmetric encryption, which would be normally faster than RSA. So so the AES 128 key is randomly generated for each file. So this is not from the CNC, but this is locally from the infected computer. Then the AES 128 key is used to encrypt the file and its file name. So not only the file, but also the file name of the file is being encrypted. Then after encryption, the AES 128 key will now be encrypted by the RSA public key from the CNC, or if it's offline, then it's from the embedded RSA key from the configuration. So this, as we said, that the file name is also encrypted, so it has to create its own file name. So this is the format of the encrypted files by Locky. So again, we have the victim ID, the first 16 characters, and the next 16 characters is the file ID. Then it is appended by .Locky. So this is the very first version. Then the latest one is .Assassin. So the victim ID is still the same, 16 characters, while the file ID has been added 4 characters more, so 20 in total, then appended by .Assassin. So after this, we will take a look on the file encryption layout. So the yellow part is the original file. So once it's encrypted, it should, since it uses the AES, it should have same file size since it's symmetric. So we can see there. But Locky appends some important information like 4 bytes hard code, which is hard coded in its binary. Then it appends also the victim ID, and it will append also the encrypted AES key. Since the AES key is randomly generated for each file, so it's unique for each file, it has to store it somewhere. So it stores it there. And lastly, it appends the encrypted file name. So this would be the file layout for every encrypted file. So to prove this, we have an actual layout of file. So yeah, so the first part is the encrypted data, which again was encrypted by the AES. Then we have here the 4 bytes hard-coded value. So this hard-coded value is important for Locky since this will be its reference. So when it gets the file, it knows where to find it. So once it finds this hard-coded value, it knows that after it is the victim ID and before it is the original file. And we have the victim ID here. And then the encrypted AES key, which is encrypted again by the RSA public key. And lastly is the encrypted file name, which was encrypted by the AES128 key. So next. Yeah, after encryption, it will show the HTML ransomware note. So this must be familiar with you guys. Next is the decryptor page. So compared last year, Locky was asking for 0.5 Bitcoin, but now it only asks for 0.1 Bitcoin, since this causes by the surge of price of Bitcoin for this year. So it's crazy. So interestingly, if the cyber criminals behind Locky didn't pay out their profits, then they would have like 1,000% increase in profits. Like from $500 now it's 5,000, 6,000. So they have increased profits if they didn't cash out their Bitcoin. And lastly, the decryptor page. This is usually hosted in Tor, so it's just not to be just to be anonymous. Next, so at the beginning, as you have seen in the configuration, that there is the CNC. So we wanted to automatically harvest this CNC so we can proactively block it and protect customers. So upon analysis of Locky, we observed that Locky will allocate a memory in its process wherein it stores the decrypted configuration. Since it's already in the memory, we can take advantage of this and get directly the decrypted configuration. So there will be no need of a separate tool to get this configuration. So I will just share the overview on how we did this. So we execute the sample in sandbox. Then after, since we have the memory, we have the process memory already dumped using the sandbox, we will use Yara rule to validate if it's Locky. So this will just work as a filter. So if it's not, then just end. Then if it's yes, we try to search the Locky config in the memory dump. So it has some, we have some indicator if it's the Locky configuration already. Then if it's not found, then it will notify us. Since we already determined that it is Locky, so we can say that the configuration must be updated, or maybe this is a new variant of Locky, so we can check it out. And if we found the Locky config, then we just store it to our database. So proceeding next, the kill chain of Locky. So we have been monitoring Locky for more than a year. So we will share just the spam campaign. So here is the typical spam campaign setup. So first we have the spam email. Then next is the attachment. So this will serve as the loader for Locky. So these are the files that we observe. Microsoft Office, this is Word, Excel, or PPT. We have LNK, PowerShell, HTML, archive, script, and PDF. So yeah, Locky is quite uses a lot of file types too. Yeah. And then next is the download URLs. So this is where the payload is stored. These are usually legitimate sites that have been compromised. And next is the payload Locky. So it is pretty straightforward. So to have a better understanding of the whole spam campaign, we will take a look on a visual representation. So this would be from our internal project back in Singapore, FortiGuard Singapore, and to correlate some data. So I'll just play a demo here. So as you can see first, these are a group of spam emails. Then we were able to link it since what the project that we did, the system, it extracts all the email that comes in, and then we found out that all these spam emails share the same RAR file or attachment. So yeah, let's play. Yeah, so here we have the, oh, sorry, what happened? Yeah, here, sets of email, which when extracted the attachment, we have a similar sample. And then from this RAR file, we again extracted it. And we found out that it has a malicious JS script. And from this JS script, when we execute this JS script, we found out that it connects to this malicious URL. So as you can see, there are a lot of internet globe there. It's all malicious URL. And it all points to a specific payload, which is Locky. So this is only a part of the spam campaign. So to be able to see the whole part, we will zoom this out. We will zoom using Locky payload as in the middle. Yeah, so this is what we found out. So there are a lot of in a spam campaign, there's a lot of emails, but it doesn't mean that every spam email has a unique sample. What we did here, we can see that a group of spam email have a similar attachment. Then this attachment connects to a malicious URL. So we have multiple URLs, but all these multiple URLs connect only to one sample, only download to one sample. So let's proceed to the next. So here, just to better understand, we isolate one part of the spam campaign. So spam emails, we have the script downloader, then we have the URL. So what we tried, once we have this URL, we monitor this URL, and we tried to connect to it a couple of times a day. So what we found out, at first it downloaded the .jablo6 variant of Locky, and then after a few days, it downloaded .loquitus. So what we can say is that the spam botnet that is behind Locky, it reuses these malicious URLs, and it always updates it. Like for example, this today .jablo, but tomorrow it will be .loquitus, and then another day it could be any other malware or another family. So another overview to summarize our findings. Here is what we found. So first wave of a spam campaign, we noticed it on Monday, which is September 17, 2017. So 8:24 a.m. This is UTC time, and all these thousands of email only had one email subject, which is status of invoice. And then when extracting all these emails, we got the attachment of not exactly this, but this kind of format, like A, then random numbers, but it had the same format, like characters and numbers with .7zip file type. And then since we have the attachment, we got the JS script, then executed all this JS script, and we found out that it connects to multiple compromised sites, but it's appended by this URI 87 DGS. And once we got the payload, all of the samples in the first wave had this affiliate ID 3. It has URI, CNC, and it's online and offline encryption. Then second wave, same day, Monday, but now in the afternoon, it had the thousands and thousands of emails, again, had a same email subject. The attachment had a similar format again, like the date and random numbers. Then the URI changed, and now the sample, when we extract the configuration, it's now only supports offline encryption. So the takeaways here are, first, two spam waves were delivered per day, one in the morning and one in the afternoon. So each file has its own set of compromised hosts, and it's been appended by the only same URI. So they do this since AV vendors could already have blocked in the morning the previous URL, so they need to update it. So a wave can deliver samples with either online or offline encryption. Then, yeah. So as you have seen in this graph and in the demo, there is a lot of places where we can stop and detect the Locky. So back in our demo, so if we just block the payload for this time, then it was able already to block like all the even though there's a new URL, and if it points to the same payload, then once the payload is blocked, then it should be okay. Next takeaway is blocking the malicious URL. So as we can see that the URL was reused, so it could serve a different malware for some other time. So once it's blocked, so it's for good already, even though there's new samples in that URL. And lastly, having known some common behaviors like in this table, we can immediately identify if the email is from spam campaign and if the URL is malicious. So yeah. And last is some interesting observation. So the email subject message from KMC224E, the spam email subject was also used by the Dridex and Jaff ransomware in their spam campaigns. Next is the Qtbot loader, which serves TrickBot and Locky, as mentioned a while ago. And then Locky ransomware files share the same download servers with Sage ransomware. So this is also quite popular this year, Sage ransomware. And next, Locky ransomware file shares the same download servers with Fake Globe ransomware. So even though we can see a direct connection with these malwares, we can prove enough that only one cyber criminal or one hacker group is behind. Our speculation would be that the malware authors are one group, the creator of the loaders is another group, and the spam bots, again, is another group. It just happens that these malware authors bought the service from one group who handles the spam bot. So yeah, just conclusion. So to give some better perspective, so let's say, for example, that you are just an ordinary computer user. You just use your computer on day-to-day job, and all of a sudden, you were surprised that your desktop wallpaper has been changed, saying that all your important files have been encrypted. Then you felt some adrenaline. You need to look at your important files, pictures, financial statements, and everything. And as it turns out, all of it are already corrupted or encrypted. So there's really nothing you can do to recover your files unless you pay a certain price. So the question is, are you willing to pay the price, or will you let your files go? Thank you.
We have 10 minutes for questions.
Questions.
You have said that there are multiple groups that work together and buy services from each other.
Yeah.
Would it be that to be an affiliate, you have to provide a compromised server for the URLs or for spam servers, and that's why there are shared resources, but they're not really hacking groups, they're just people that has a possibility to exploit or enter some servers and then decide to use these and use the service offered by Locky.
I think for the affiliates, it could be anyone, as long as they're willing to get the ransomware and give the commission to the malware author, and they have contacts. Like they could not necessarily be the spam bot, but they could get the service of a spam bot group, then get a loader group. So it doesn't mean that I'm a spam bot, then I need a malware to spread. So I think it's not that the case, since they will have some conflict of interest. So I think maybe as a cyber criminal, then they will get this, and they know some contacts who have these services, then they will just combine it, then spread it. So yeah, I think that's it.
Other question?
Hello. Are there any other tips suggesting some attribution? Like, for example, this ignore Russia. And when you talked about the times where the email campaigns arrived, like which time zone were those, for example?
I think since we track it in UTC time, so when I check in Google, UTC time is UK. So I don't know, if they're from there, or they really target UK. So at that time, like people will open email. So it's really hard to attribute if, especially if, as you see in the affiliate program, there is not only one group but multiple people who are behind this. So they leave a lot of traces, but they don't connect to like someone. Yeah, so it's hard to point. Yeah.
The Russian flag is it always set to one, or it depends on the campaign?
I think from all that we have observed, it's always one. Yeah, so it's safe to say. Yeah.
Is there any reason why they are using only AES-128, not, for example, 256?
I think AES-128 would be enough since they encrypt it by RSA 24.8. So the real protection to them is the RSA. So to be able to get the use key, the AES-128, they still need the RSA private key. So I think they don't need a higher encryption because it will take more time to encrypt the files. So yeah.
Okay.
No question?
How long does it take generally to encrypt the whole computer?
I think in a couple of minutes, like less than 5-10 minutes, then it's done. Yeah.
I've seen new ransomware use encryption of the MFT table or of the boot sectors or stuff like that.
Yeah.
Does Locky have anything more advanced than just files?
I think for now, that's their target. Like, I think the NotPet, yeah, it's like the boot ransomware. I think for Locky, they haven't done any major changes from last year, so it's still the same. Yeah, that's it.
One last question.
Did you find some component of this kind of ransomware, like open source part or how it is built?
I think there's no basis for open source, and as you can see in the Locky's development, they continue to develop it. And from this development, I haven't seen any other ransomware or other families that do this. So yeah, I think the malware authors are really they were the ones who built from ground up. Yeah.
One last.
So you have shown the timeline of the evolution of the ransomware.
Yeah.
How much time does it take you to analyze the differences between the different versions of the ransomware?
I think initially we took like maybe a week or two to analyze the whole ransomware. Then after that, we built the harvesting of the configuration. So with that, we were able to we don't check it daily, but it sends us a notification like something's wrong. Like we weren't able to we weren't able to get this configuration. So once we have that notification, that's the time when we check again the sample. Then if it's something new, then we just update our database, then we move on forward. But since there were really no major changes from its initial outbreak, then yeah, it may be just a few hours a day if there's something new. Yeah, that's all.
Okay, thank you again, Rommel.
Okay.